Welcome to this channel, Chemistry Made Easy. I am Dr. Mulik. Today we are going to discuss the genesis of elements. As we have started in the previous lecture, we are going to continue this topic today also. So we will begin with this lecture. The genesis of elements. So last time we have seen the stage of expansion of the universe after Big Bang to form the elements, that is atoms, after the particles of positive nature which then capture electrons and produce various atoms. These atoms react less strongly with radiations than do subatomic particles. What is meant by these subatomic particles? These subatomic particles. What is meant by these subatomic particles? These are the neutrons, protons, antineutrinos, neutrinos, mesons, etc. There are a number of such particles which are present inside the nucleus of an atom, which are called subatomic particles. So the atoms react less strongly with the radiations than do subatomic particles. These atoms react with each other more or less independently than radiations. So there is no interaction or less interaction of these atoms with the radiations, but they can undergo the nuclear reactions which are having intention to produce the particles from which atoms are formed. The atoms began to condense into stars. So when the atoms are formed by this way, these atoms are condensing into stars. The radiations are moving away with the expanding universe. So the expansion of this causes redshift. So this type of expanding universe shows decrease in energy. That is called redshift. So the temperature decreases by about 2.7 Kelvin. So this phenomenon was supported by the Penzias and Wilson. So the Penzias and Wilson in 1965 showed that there is a redshift due to expanding universe, and this is a great support for the evidence, that is evidence for Big Bang theory. Now within 11.3 minutes, so after or during this expansion stage, from the point of Big Bang or explosion of the compact mass in the universe, at the starting point, after or within 11.3 minutes, what is 11.3 minutes? This 11.3 minutes is the half-life of a neutron. So what undergoes or what takes place during this decay of neutron or destruction of neutron? So when the neutron is broken down, it is converted into a proton and electron and this antineutrino. So the decay of neutron takes place with the formation of a proton, electron and antineutrino. So half of the universe at this point consisted the protons, and the temperature was dropped to 5 into 10 raised to 8 Kelvin. So because of such formation of protons, various nuclear reactions are taking place like this, as a result of which the temperature decreases to 5 into 10 raised to 8 Kelvin. Then next point in this expansion process. So during the first 30 to 60 minutes after Big Bang, so when Big Bang takes place, and if we count the time 30 to 60 minutes, various nuclear reactions are taking place and various nuclei were formed. So what were these nuclei which are formed at that time of within this range? So deuterium, this helium isotope with mass 3, this helium isotope with mass 4, and this helium isotope with mass 5. So such nuclei are formed as a result of the various processes within these 30 to 60 minutes. But here, this 2He5, that is helium isotope of mass 5, is broken down into helium isotope of this mass 4, and one neutron is emitted. So this process takes place within the half-life time of this helium isotope 5, that is 2 into 10 raised to minus 21 second. So 2 into 10 raised to minus 21 second is the half-life time of this helium isotope with mass 5. Then the hydrogen burning process. So after formation of such nuclei, the next type of reactions which have taken place at that time are hydrogen burning. What is meant by hydrogen burning? The protons which are present in the plasma are fused with each other and giving the relatively heavier particles or nuclei. So we can take these examples. When the two protons are fusing or undergoing fusion process, they are converted into a deuterium, that is 1H2. This is deuterium 1H2 with the emission of a positron. This is positron. This is electron having positive charge, and therefore it is called positron. This is also represented as beta plus. This positron can be represented as beta plus with the also release of a neutrino. Then second reaction taking place at such condition is 1H2, it is one deuterium, undergoes fusion with this one proton and gives helium isotope of mass 3 with the release of gamma photon. Then third reaction taking place here is this type, that is two helium isotopes of mass 3 are undergoing fusion to produce helium isotope of mass 4 with the formation of two protons. So these three reactions are taking place on various stars which are formed at that time, and the temperature is 10 raised to 7 to 10 raised to 8 Kelvin. So the temperature is still high. So when the temperature is high, the lighter particles or nuclei are formed, and as the temperature goes down, the particles or nuclei formed are relatively heavier. So with the decrease of temperature, the heavier and heavier particles are formed. Then Next point is matter formed during this reaction 5, that is this reaction. So during this is reaction 5. We can say this is reaction 5. So matter formed from reaction 5 gathered to form galactic clusters. So galactic clusters are formed temporarily, not for permanent, but temporarily from such type of reactions. Then after formation of such galactic clusters, the dense stars are formed. We can observe the formation of dense stars. So these dense stars are under very high pressure of gravity. These dense stars are under high pressure of gravity and high temperature. So this high pressure of gravity maintains high temperature, and as a result of this, the reactions were promoted to further relatively heavier type. So this condition promotes further reactions. Then we will see the formation of heavier elements. So as we have seen that as the temperature goes down, the elements or nuclei formed are relatively heavier and heavier. So helium burning reactions is the beginning of formation of relatively heavier particles or nuclei. When these here in this example we will see the two helium nuclei undergo fusion, that is called burning, that is nuclear burning. It is not ordinary burning, it is nuclear burning, which requires presence of such a very high temperature. So as a result of burning of this helium, what are the nuclei formed? Relatively heavier nuclei, that is beryllium with mass 8 and release of a photon. Then the next reaction shows that the helium nuclei also burns with, or we can say undergoes fusion with this beryllium of mass 8 and gives carbon with mass 12 and shows emission of gamma photon. The next reaction is like this: carbon with mass 12 fuses with proton and gives nitrogen of mass 13. So this nitrogen of mass 13 is unstable and undergoes decay to form carbon 6 with mass 13 and positron. This is positron. It is shown here with plus 1 charge. This is mass. So these 13, 0, these are representing mass of such particles or nuclei. These are presenting the charges or protons. So this carbon, here we can consider the example that this carbon contains 6 protons, that is 6 positive charges in the nucleus. But this electron is positively charged, that is positron, and simultaneously there is emission of a neutrino. So this is about various particles which are formed here. Now we will see some additional information. Here so you can see here, when we consider the presentation of certain nucleus, we can show here, for example, we can consider this 7 and 13. So this 7 and 13 means this neutron that is nucleus of neutron. So this is nucleus of neutron. So this nucleus of neutron contains 7 protons plus 7 neutrons. So 13 indicates that the nitrogen nucleus contains 7 protons and 7 neutrons. So these 7 protons are represented here as the atomic number. This is atomic number. We say this is atomic number, and this is mass number. So this mass number is represented, or mass number is indicating this 7 protons and 7 neutrons. Now we are also seen that there are various particles, subatomic particles. Now you can see the subatomic particles like this. So neutron, this neutron is one subatomic particle. It has 0 charge and mass 1. So this is the simple form of representation of the mass 1. But this is actually 1.009 AMU, that is atomic mass unit. This is actually mass of the neutron. So what is 1 AMU? 1 AMU is equal to the 1/12 mass of carbon 12 isotope. 1 AMU is 1/12 mass of carbon 12 isotopes. So this is the base. AMU is the unit used to represent mass of particles or the elements, that is isotopes. Now there is another particle we are representing as proton. So proton is alternatively represented as H1H1. So these both representations are used as per our requirement. This proton has generally represented with this mass, that is 1. This indicates charge, plus 1 charge, and this mass is actually 1.007 kmu, atomic mass unit. So proton has mass 1.007 AMU. Now we have also other particles like electron. So this electron may have minus charge, and this is represented as the mass is considered to be 0. But this is not actually the 0 mass of electron, but it is actually 1 upon 1823 part of the proton. So this is the fraction of the mass of the proton, that is 1 upon 1823. So this is, the mass is very small, therefore it is considered to be 0. Similarly, the particles like this gamma have no charge and no mass. With the mass is also considered to be 0. There are other particles like these neutrinos, which are also having no charge and the mass is taken to be 0. Similarly, there are also various other small particles having mass equal to these electrons or less than that, are considered to have 0 mass, and the charge is taken as whatever it may be there with that particle. So this is the information which is required while we are representing various nuclear reactions. So this is the some portion of this topic which are taking here or which we have discussed here in continuation with our previous lecture. So this is not ending here, but it is also continued in the next lecture. So please keep watching this lecture or video, and please put your mark on the like button or press the like button and share this video and suggest if any whatever you want to say in the dialog box. So thank you very much. Keep watching. So thank you very much.